Good, bad, and different. Page 298. Good, 1 through 5. I forgot what it was. So we were putting those together. Oh, that was yours? Perfect. Thank you. Oh, this is Michael's. Thank you, guys. Was there any questions from last night's homework? So we know that radicals always come in pairs, if they were to give you that, as well as complex solutions always come in pairs. There's always the conjugates of each other. So if they ever have listed for you, you have a polynomial, you have a 0 of root 3, 7, and 5. Well, the 7 and 5 are fine. The root 3 also has to have its negative root 3 with it. If you had complex solution of 2i and 4 and 6, 4 and 6 are fine. There's no other duplicate, but the 4i has a negative 4i with it. Or if you had a complex number written as like 2 plus 3i, that means 2 minus 3i is also one of the solutions that come with it. So those are just things that we wanted you to know about yesterday's homework. And the one that sometimes gets kids a little bit is if I gave you a 0 of this, I think one of them was that, is this just part of the problem? So you have to realize that's where it's crossing the x-axis. So if I solve that, and I want to find the binomial that goes with it, realize this then yields to this. What did I do to both sides in order to get there? What did I do in order to get there? Do what? I multiply by 3, and then this relates to this binomial. Okay? So one of the problems had that in there. So if you had other just numbers in there, you know, if it said, you also know that 4 is one of the answers. That means that x is equal to 4. So x minus 4 is the binomial goes with that. But then if I had 2 plus 3i given, then you have to know that 2 minus 3i is also a solution to the problem. Okay, so let me recap just this up to this point, and then we can go into a lesson in a little bit. So far, this chapter has dealt with end behavior. And all that means is, where is our graph going? Okay? And so you're going to see problems like this. As x approaches, and we're going to put a blank now. We had stuff filled in there. As x approaches, then the function of x approaches what? And so if you're talking about like a graph like this, and you saw one of the ends doing this, on the xy axis as this is drawn, as x goes to the right to infinity, the function of x in the y direction goes to infinity. So how am I going to deal with the problem that maybe has, this is the side that we are looking at? What would I change things to? Yeah, so let's make this work for down here. So as x goes to negative infinity, as I go to the left this way, where is the graph going? It's going to negative infinity as well. So on the test next Thursday, Friday, so a week from tomorrow and a week from Friday, we will do the test. It's 2 parts, but I know you will see that as a problem. So before I had already had plugged in this part plugged in, so you knew you were talking to the right or to the left, and then you went from there. Okay? So the end behavior becomes an important part to realize. The answers for end behavior are going to positive infinity or negative infinity. And that's what we're dealing with so far. Okay? So the homework, page 298, 1 through 5, 17 through 24, pretty straightforward. Pretty easy to work with. Okay? So if you feel confident about the homework, make sure your name is on it and pass it on in and down. So, if you have this as a problem, this is actually one of the ones off the assignment because I don't feel like making any of them in my head. So if you copy this down, you definitely have one of the problems from homework done. Okay, so they're going to tell us, hey, this is a third degree polynomial. So things that you should know is this graph kind of looks like this, not with a blank in there. Okay, so the end behavior as I go to infinity to the right, or infinity is of course to the right, the function of x goes to positive infinity as x goes to negative infinity, the function of x goes to negative infinity as well. But they give you the number 5, and they say, okay, is the number 5 a solution to this problem? So how should I approach this kind of problem to find out if it is a solution? There's 2 ways. Yeah. Plug it in. Okay. I could substitute 5 in, and if the answer resulted in 0, it would absolutely work. I like it. So I guess there's 3 ways. What's another way?
Synthetically divide.
Synthetically divides the other way. And the third way?
Grouping.
I guess, yeah, grouping would work. I like that. And then the fourth way? What? Graph it. And if you graph it on your graphic calculator and you see that it crosses at 5, then you truly know. So on this one, I would approach this problem saying I'm going to use synthetic division using 5, and I don't have any holes or gaps here. So I'm going to do synthetic division. And I saw that a couple of you are still a little bit off on synthetic division, so if you're not quite sure, watch. Okay, so I write in descending order. There's a 1, a 5, a -2, a -10. There's no gaps, so I don't have to put any zeros in. In this case, I'm going to divide by 5. If they had it as x minus 5, then you have to solve that for 0, which in this case would be 5. So first thing I'm going to do is I'm going to draw a line straight down. Here it comes. Okay? Really no math taking place. You're just bringing down the lead coefficient. And then I'm going to go 1 times 5 to get 5. So 1 times 5. Okay, to get 5. Combine these together by addition. Now what? 10 times 5. So 10 times 5 is 50. Okay? Combine the -2 and the, so I get 48. Then what? 48 times 5. 240. So 230. Okay, is 5 a solution to this problem? No, it is not. Okay? It is, there you go. It's a point on the graph. So the point 5, 230 is a point that exists on the graph. I don't know how much it helps you to do that, but that would be the first way to go about this. So you would know that by plugging it in, so you could either substitute it in, you could use synthetic division, you could graph it on graphing calculator, or we could even use the grouping and factor down by grouping if that's going to work. So that would be the first way. So does everyone agree that 5 is not a solution to this problem?
Yeah.
Okay.
So if we were to plug 5 into like x cubed, x squared, will we get 230?
Uh-huh.
Okay.
Because 5, 5, 5, that's 125. And then 5 squared is 25 times 5 is another 125. Minus 10, minus 10. So that's going to be 250 minus 20. So same idea, exact way. All right, so let's say we redo this problem, and I'm just going to erase here. Okay, let's say the problem was given to us to where we know that this is -5. Now we want to know if -5 is a solution. So let's do it the same way. Okay, -5, I'm going to divide by synthetic division, 1, 5, -2, and -10. Come straight down. 1 times -5, -5. Add those together, 0. 0 times -5, 0, -2 combined with 0 is -2. -2 times -5 is +10. Add those together, I get that. Is -5 a solution to this problem? Yeah, so right now, graphically, -5, the graph is going to cross right there. If I wanted to solve for the other zeros, I'm going to plug my x's back in. So if I plug my x's back in, what does this equation become? If I plug the x's back into here, what do I get? X squared? There you go. X squared plus 0x, I don't have to put that, minus 2 is equal to 0. Can you solve that? Okay, this is a simple one to solve. If you couldn't solve it, you would have to use quadratic formula. You could try and factor it. But this one, I'm going to add 2 to both sides. And then I'm going to take the square root of both sides. Don't forget the plus or minus. So I get x is equal to plus or minus square root 2, which is about 1.4. So it's going to cross about here as well. So how would I make this graph look like here? Do we have any touches? No. Does it? Every one of them is going to go through. So I come up. It's going to change direction, come back up. Do I know where this would have crossed the y-axis? Yeah, it would have crossed at -10, which just doesn't really look like it. But this right here tells me where it would cross the y-axis if it's already completely multiplied out. So we okay? So that takes me into the next part of the problem. And this math that came out by Descartes was unbelievable. So Descartes realized there was a pattern that took place with these types of problems. Now, yes, Descartes sat around all day doing math. Okay, I know it sounds like the most amazing job out there, but it's not that cool. But good for him for doing it. So Descartes realized that there's a relationship between the constant and the lead coefficient, and also if I substitute in -x. So let's take this problem. Now I'm picking a bigger problem. You won't have to do anything quite this awesome on the test, but okay, so Descartes said this. First step, we want to know how many positive real zeros there will be. A positive real zero goes from 0, or is bigger than 0, and goes all the way to infinity. And it can be a rational or an irrational number. But by using Descartes' rule of signs, we can find the real possible solutions to this problem. So right now in the green, I'm going to look to see out here how many possible solutions, meaning where it would cross. Okay? So what this math is doing is this. What this math is doing this. I want to look for the positive real zeros. So what I'm going to do is I'm going to look for any sign shifts that take place. So this is positive here. So positive to negative. Does that change signs? Positive, negative. Yeah, there's one sign change. Negative to positive. Did it change signs? There's 2 sign changes. Positive to positive. No. Positive to negative. Okay, so this is going to say I have 3 sign changes. So I have 3 or 1 crossings of the x-axis. So how he did it, no matter how many sign changes you have, you always subtract by 2, and it'll tell you. So if you had 5 sign changes, it could cross 5, 3, or 1 times across the x-axis in the positive direction. Then Descartes said, well, if I were to take a negative x and plug it in, if I were to do that, so now you have to start thinking about this right here. If I took negative x and I went negative x times negative x times negative x times negative x, is it positive or negative? I multiply negative x times itself 4 times. Does it stay positive or does it stay negative? So negative times negative is positive. Positive times negative is negative. Negative times negative is positive. So this technically is still the same as that. Okay? If I substituted in a negative x, did the arithmetic, it's going to turn to that. Now what about here? If I go negative x, negative x, negative x, is it positive or negative? Negative, and then I have negative times negative 4 is going to give me positive 4x to the third. Okay? So this dictated at the very end that the sign changed to positive. And then I have negative x, or negative x squared. Is it positive or negative? Positive, and that's positive out front, so plus x squared. And then I have 6 times negative x, which is negative 6x, and then minus 2 stays as is. Now we're going to look for any sign changes that take place here. Technically, this is positive. Is there a sign change? 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 So this is the only sign change. So this tells us we have negative real solutions, or real zeros. And in this case, we have 1. So that means that over here, it'll cross 1 time. Okay? So that's the first part of Descartes' rule of signs. Pretty simple to think about. So in order to find the positive real zeros, how many times does the sign change? Plug a negative x in, do the arithmetic. How many times does the sign change? So it tells you whether it crosses, how many times it crosses to the right of 0, and how many times it crosses to the left of 0. Okay? Now let's figure out what the zeros are. So using the same problem, what I'm going to do now is I want to try and figure out what my zeros could be on this problem. So that's going to say take this and take this. So I'm going to take my constant over my lead coefficient, and I'm going to write all the factors. So what are all of the factors of 2? How do I, what times what gives me 2? 1 and 2, and I want all the positives and negatives. So I have plus or minus 1 and plus or minus 2. Okay? What are all the factors of 3? Plus or minus 1 and plus or minus 3. Okay? So that's basically a fraction. So this means that I could have the positive or negative of 1, the positive and negative of 1/3, the positive and negative of 2, and the positive and negative of 2/3. These are all my possibilities of my problem. So back before graphing calculators were there, they would go through and literally do this. So here's one question. Where's the chance we have the most amount of zeros to take place? In the green area, which is positive, or the black area that's negative? The green. So I'm going to take the positive component. So I'm going to use synthetic division for 1. I'm going to hold off on 1/3 and 2/3 for now, but 1 and 2 right now seem like good ones to start out to see if there's solutions to the problem. This is a 4th degree polynomial, so things that you should think about is the end behavior of it. It's going to look like this. It could technically cross a total of 4 times because the exponent is raised to the 4th power. It might not. You might have double roots. We don't know. So let's use synthetic division to see if 1 is a solution. So I have 3, -4, 1, 6, -2. Doing it quick. Is 1 a solution? No. So I'm going to go to the 2 because 2 should be just about as easy to do. So I have 3, -4, 1, 6, -2. 3 down. 2, 4, 5, 10, 16, 32, 30. Is 2 a solution? Dang it, I got to go to the fractions. Got to use the F-bomb. Fraction. Go foiling right now. The other
Doesn't
F-bomb.
that mean there's only 1 positive? Seems like you only have 2 left.
God bless you. Good point, but we have to also think there might be a double root. It might happen twice where it'd be a bounce. But that's a great way of thinking. So I'm going to erase these. I don't necessarily need these right away. All right, so let's try 1/3, see if that works. 3, negative 4, 1, 6, negative 2. Bring 3 down. 3 times 1/3 is 1. It's negative 3. Negative 3 times 1/3 is negative 1. It's going to give me 0. 0 times 1/3 is 0. 6 comes down. 6 times 1/3 is 2. Is 1/3 a solution? Sweet. What degree is this now? X cubed. Okay, it was x to the 4th. So we now know we definitely have one real solution that took place. I don't know if there's a second one because it's 3 or 1. So being I only have, one other one to try and work at. I mean, I could try 1/3 again to see if that works. It might be a double root. I don't know. So that might be something we might want to try. And we're going to use synthetic division on this now. Oops, that's positive 3, excuse me. So bring this down. 3. 3 times 1/3 is 1. Negative 2. Negative 2/3. Negative 2/3. Uh-oh. Multiply those. That's not going to work. Let's try the positive 2/3. So I can just write over it. It's going to be a disaster. Okay, that's going to give me 6/3. 6/3 is 2. That's going to give me a negative 1. That's going to give me positive 2/3. Positive 2/3. 2/3 times 2. Nope. So right now I know I have that. So I have a solution at 3, 0. The other solution is going to be one of the negative components. So I'll try negative 1. That doesn't work. Negative 1/3. That didn't work. Negative 2. That didn't work. Negative 2/3. One of those should work. And then if one works on the right side in the positive and one works on the left side in the negative, what can you tell me about the last two solutions to the problem? What kind of solutions are they? Any ideas? We're talking about real solutions with Descartes' rule of signs. Real solutions will cross the x-axis. So if I have one solution that was here, and I know I'm going to have one solution here, that gives me 2 out of how many solutions? 4. What would I know about the other 2 solutions? What kind of solutions would they be? They'd be complex. So it's looking like we're going to get a complex solution. Our problem, when we graph it, might look something like this, where here's one of them and here's the other real solution. Somewhere in here, the complex solutions are taking place. But if I were to take this down and divide it one more time, this right here becomes this squared plus 6. So I get this. If I find one other factor, what does that answer go down to? 2. And if it's down to 2, what formula is going to work for you if you can use it? Quadratic. Okay? So, your assignment, I guess, is due Monday? Really? Holy moly. So I probably should tell you, don't work too hard tomorrow and on Friday, because I know you have the testing anxiety taking place. You're sitting there doing this big test, all you seniors. I get it. So make sure, I wouldn't do any of the math homework today or tomorrow, especially you seniors, because testing tomorrow and on Friday is going to be pretty tough. Okay? I just want you guys to know that. Page 298, 43 through 54, 79 through 83. And I have this all recorded. You have plenty.